Welcome to the deep dive. If you think back to 2023, it was a year that really hammered home how much our planet is shifting.
Yeah, absolutely.
We saw heat records just shatter, temperatures soaring near 50 degrees Celsius.
Unbelievable numbers.
And those massive wildfires, Canada, Greece, turning skies orange across continents, it really felt like Earth was sending a pretty clear message.
A very loud one.
So our mission today is to try and cut through some of that noise, the information overload around climate change.
There's so much out there.
Exactly. So we've done a deep dive into a whole stack of sources, articles,
Mm-hmm.
new research, expert talks, basically trying to pull out the most important nuggets of knowledge for you.
Yeah, the key takeaways.
We want you to walk away feeling well-informed, quickly, and thoroughly.
That's the goal. And in this deep dive, we're going to unpack what climate change actually is, what's driving it,
Core drivers, yeah,
and then trace those cascading effects, how it ripples out across the planet.
affecting everything.
Everything. Natural systems, our health, food, the infrastructure we rely on. We'll look at some maybe surprising connections too, help you see that bigger picture.
Okay, great. Let's start with a basic distinction then, because you hear climate change and global warming used, almost interchangeably sometimes.
They're often used that way, yeah.
But there's a key difference, isn't there?
There is. So climate change is the broader term. It refers to long-term shifts in average weather patterns for a region. Could be natural, could be human-caused.
Okay.
Global warming is more specific. It's about the long-term heating of the Earth's climate system.
Yeah.
And that heating is overwhelmingly attributed to human activities.
Okay, so global warming is like a major component of climate change.
Exactly. Think of it as the leading edge, the warming part of the much bigger picture of climate shifts.
Got it. And the big engine driving this warming, that's the greenhouse effect, right?
Right.
So how exactly does that work?
Okay, imagine Earth has this sort of invisible blanket or like a greenhouse.
Right.
Certain gases in our atmosphere, water vapor, CO2, methane, nitrous oxide, even some older ones like CFCs, they act like the glass.
Letting sunlight in.
They let the sun's energy come through, yes, but then they trap some of the heat that tries to radiate back out into space.
Okay.
So the more of these greenhouse gases we pump into the atmosphere, the thicker that glass becomes. It traps more heat.
And the planet's temperature goes up. We're thickening the blanket.
Precisely.
And what's really crucial here, I think, is understanding the human fingerprint on this increase, especially with carbon dioxide.
Absolutely. Human activities, particularly burning fossil fuels,
Yeah.
coal, oil, gas, have released so much CO2 that levels are up by more than a third since the Industrial Revolution started.
More than a third. Wow.
And the speed of this change is what's really alarming. Atmospheric CO2 levels, they haven't been this high in hundreds of thousands of
Yeah,
years.
this is the thousands.
Yeah, and we're already seeing the effects. About 1.142 degrees Celsius of global heating already locked in.
Which doesn't sound like a huge number maybe, but it translates to...
Yeah. It translates to the hottest global temperatures in the last 100,000 years. We saw records breaking all over the place, especially highlighted in 2022.
Right. Now, I often hear the question, and it's fair, hasn't the Earth's climate always changed naturally?
It's a really important question to address. And yes, it's true. Earth's climate has always fluctuated. We've had ice ages, warm periods, driven by things like shifts in Earth's orbit, volcanic eruptions, even continents moving around over millions of years.
So natural cycles exist.
They do. But scientists use these amazing tools called climate proxies to understand past climates.
Proxies, like stand-ins.
Yeah, they're like nature's archives. Think tree rings.
Oh, right. Wider rings mean good growing years.
Exactly, or layers of sediment on the ocean floor, tiny air bubbles trapped deep in Antarctic ice cores.
Like little time capsules of ancient air.
Precisely. And these proxies let us reconstruct past climate patterns really accurately. And what they consistently show...
What do they show?
They show that the warming we're seeing now, particularly the speed of it, just cannot be explained by those natural cycles alone. It's unprecedented.
So the natural cycles are still there, but something else is overriding them.
Exactly. The data is very clear. And there's a consistent theme throughout Earth's history from these proxies. When CO2 levels were lower, it was colder. When CO2 was higher, it was warmer.
Simple relationship, really.
Fundamentally, yes. And today's CO2 levels and the rate they're rising are just way outside that natural range.
You mentioned that image.
Yeah.
Crocodiles near the North Pole in past warm periods. It's not just a fun fact, is it? It's a warning.
It's a stark warning about the scale of change we're potentially heading towards. These aren't small tweaks to the system.
Okay, so this fundamental shift is happening. Let's trace the ripples. What does it mean for our world right now? Starting with, say, the oceans and ice. They seem foundational.
They really are, and the interconnectedness is key. We're seeing huge ice sheets, Greenland, Antarctica, and mountain glaciers melting much, much faster than before.
And that's not just about losing scenic glaciers.
No, not at all. All that melting ice flows into the ocean, and it's a major contributor to rising sea levels.
Which directly threatens coasts.
Directly. Coastal communities, crucial wetland ecosystems, entire low-lying island nations. They face increased flooding, erosion, saltwater intrusion. We've seen glaciers like Öksüt in Iceland declared dead in 2014. Alaska's Muir Glacier. The photos over decades show a dramatic retreat.
It's visually quite stunning, the change. So the ice is melting, but the oceans themselves are changing too.
Oh, absolutely. Oceans are like giant heat sponges. They've absorbed the vast majority of the extra heat trapped by those greenhouse gases.
So they're getting warmer.
They are. And warmer water expands, just like water heating in a pot. It's called thermal expansion.
So it's not just meltwater adding volume, the water itself is taking up more space.
Exactly. That's another major driver of sea level rise alongside the melting land ice. But the oceans are taking the brunt in other ways too.
Right? There's acidification, which sounds bad, what's happening there, especially in like the deep ocean. That seems so far away.
It does seem remote, but it's critically connected. Ocean acidification happens because the oceans absorb about a quarter of the CO2 we emit.
Just soak it up.
Yeah. And when CO2 dissolves in seawater, it forms carbonic acid. It literally lowers the ocean's pH, making it more acidic.
Changing the basic chemistry.
Fundamentally changing the chemistry. And this has huge impacts on marine life, especially things that build shells or skeletons like corals or shellfish. But the deep sea connection is vital.
How does surface acidification affect the deep?
Well, ocean currents connect the surface and the deep, but also think about food. Tiny plants at the surface, phytoplankton, are the base of the food web.
Right, photosynthesis happens up there.
Exactly. And when those phytoplankton die, they sink, carrying carbon and food down to the deep sea. But warming changes the type and size of phytoplankton. They might become smaller, sink slower.
Meaning less food actually reaches the bottom.
Significantly less.
Yeah.
And the deep sea is already incredibly food limited. Imagine 1 square meter of seafloor at 4,000 meters deep gets the carbon equivalent of maybe a single sugar cube per year.
A single sugar cube for a whole year.
Wow. It's an extremely lean environment, but it's also been very stable for millions of years.
Until now. So if the food's decreasing and it's getting warmer and more acidic down there, what are the projections?
The projections are, frankly, stark. We're looking at potential deep-sea temperature increases of up to 4.5 degrees Celsius in just 80 years in some spots.
4.5 degrees compared to what natural change?
Compared to maybe 1 degree over 5 or 6 million years naturally. It's an incredible shock to the system. Plus lower oxygen, lower pH, and, as we said, that drop in food supply, potentially up to 30% loss in some areas.
30% less food.
Which translates to a projected massive loss of deep-sea biomass by 2100. We're talking billions of kilos. It's like losing, say, 12% of the human population of Europe. Just gone from the deep sea.
That scale is staggering.
Yeah.
And can these ecosystems bounce back quickly if things change?
That's the problem. No. Because they've evolved in such stable conditions, deep-sea recovery rates are incredibly slow. Decades, centuries. For some deep-sea corals, even millennia.
Millennia?
And this isn't just some isolated deep-sea issue. Nutrients generated down there eventually well up to the surface, supporting shallow ecosystems, fisheries, our livelihoods. It's all connected.
It really is. Okay, so oceans are under huge stress.
Right.
Let's shift focus to weather. We're definitely seeing more wild weather, right? It feels undeniable.
It is. A warmer atmosphere fundamentally holds more energy and more moisture.
More fuel for storms.
Exactly. So you get more intense major storms, bigger floods, heavier snowfall in some cases. But counterintuitively, also longer and more frequent droughts in other areas.
That's right, that paradox.
Yeah.
How can you have both more drought and more intense rain?
Because when it does rain, there's more moisture available in the atmosphere due to increased evaporation from warmer surfaces. So rainfall events become heavier, more concentrated, even if the periods between them get longer and drier.
So dry places might still get slammed by sudden massive floods. That's disorienting.
It makes planning and adaptation incredibly difficult. The old rules don't apply. Think about hurricanes. They draw their power from warm ocean water.
Warmer oceans mean stronger hurricanes.
Generally, yes. They can intensify more rapidly, grow bigger, hit harder. You get stronger winds, bigger storm surges, more coastal flooding.
And it feels like multiple types of extreme weather are hitting at once sometimes.
That's another observation. You might have heat waves, followed by intense rain, contributing to flash floods, maybe alongside ongoing drought conditions nearby. It's a compounding effect.
A recipe for disaster, really.
Mm.
And what does this mean for ecosystems on land?
Similar stresses. As temperatures climb, the areas suitable for certain plants and animals shift. They tend to move uphill or towards the poles, chasing cooler conditions.
But can they always move fast enough?
Often, no. Especially plants or animals with limited mobility. So habitats shrink or disappear, increasing extinction risk. Plus, the timing of natural events gets disrupted, like flowers blooming earlier before their pollinators arrive, or birds migrating based on temperature cues but arriving before their insect food source has emerged. These mismatches can devastate populations.
And wildfires.
Yeah.
They seem like an increasingly common part of the story.
A huge part. Hotter, drier conditions create tinderboxes. Wildfires rage through forests, destroying habitats. And ironically, burning forests release vast amounts of stored carbon back into the atmosphere, worsening the problem.
A feedback loop.
A dangerous one. And we also have to talk about deforestation itself.
Right, cutting down forests isn't just losing habitat, it's removing a climate regulator.
Exactly. Forests are often called the lungs of the planet. They breathe in CO2. When we clear them for logging, for agriculture, soybeans, cattle, palm oil especially,
Palm oil, yeah.
we lose that vital carbon sink. And the act of clearing and burning often releases even more CO2. It's estimated that deforestation accounts for nearly a third of human-caused CO2 emissions. It's a massive driver and amplifier of warming.
So it's a double hit. Losing our natural defense while adding to the problem.
Mm-hmm.
Okay, what about the direct hits on us? Human health and safety.
The impacts are profound and direct. First, heat itself. More frequent and intense heat waves mean more heat stroke, dehydration.
Especially in cities.
Yes, the urban heat island effect. Concrete and asphalt absorb and retain heat, making cities significantly hotter than surrounding rural areas. Kids, older adults, people working outdoors, they're particularly vulnerable.
And air quality suffers too, right?
Definitely. Warmer air can trap pollutants near the ground, and higher temperatures actually promote the formation of ground-level ozone, which is a major component of smog.
Smog leading to asthma, heart problems.
Asthma, heart disease, lung cancer, serious respiratory and cardiovascular issues. But it's not just air. Warmer temperatures and changing rainfall patterns are expanding the geographic range of infectious diseases.
Also.
Vectors like mosquitoes and ticks thrive in warmer, wetter conditions. So we're seeing diseases like malaria, dengue fever, Zika, West Nile virus, Lyme disease popping up in places they weren't common before.
Wow.
And warmer coastal waters can lead to increases in waterborne pathogens like Vibrio bacteria.
For doctors in some regions might be seeing diseases they weren't trained for.
Exactly. There's a real need for education within the medical community about these shifting disease patterns. And all of this puts immense strain on health systems.
Which are often already stretched thin.
Precisely. Their ability to cope, to protect public health, is diminished. And we shouldn't forget the mental health toll. Anxiety about the future, trauma from experiencing climate-related disasters, it's significant.
Absolutely. Okay, beyond health, let's touch on food security and the atomic side. Infrastructure.
Agriculture is hugely impacted. Extreme heat damages crops. Floods wash away topsoil. Droughts kill harvests. New pests and diseases thrive in changed conditions.
So lower yields, more crop failures.
Yes, and soil degradation makes future farming harder. Plus, rising seas can flood valuable coastal farmland.
And we already talked about fisheries collapsing due to ocean changes.
Right. Warming, acidification, habitat loss, fish populations decline or shift dramatically. We mentioned the poleward shift, fish moving to cooler waters.
Meaning tropics lose fish, higher latitudes might gain some temporarily.
Right. And the downward shift to deeper water, the horizontal shift across oceans, it disrupts a major protein source for billions of people.
So less food available from land and sea? That inevitably means?
Rising food prices, increased risk of malnutrition, major disruptions to local and global food supply chains, leading to shortages.
And our physical infrastructure. Roads, power lines.
Also vulnerable. Extreme weather floods, powerful storms, even extreme heat buckling roads or railways damages critical infrastructure. Bridges, power grids, water systems.
Making it hard to get essentials, hard to recover.
Exactly. And the repair costs are enormous. Coastal infrastructure like ports and airports faces the additional threat of sea level rise and bigger storm surges.
This paints a picture of widespread disruption.
Mhm.
And it highlights something really unfair, doesn't it? Who bears the brunt?
That's a critical point that comes up again and again in the sources. While materially rich countries are historically responsible for the bulk of emissions,
Right.
it's often materially poorer countries, those with the fewest resources to adapt, that suffer the worst impacts.
Leading to climate displacement, climate refugees.
Yes. People forced from their homes by drought, floods, sea level rise. And these vulnerable communities are often in high-risk areas to begin with less capacity to cope or rebuild.
It raises huge ethical questions, like even in insurance, if being wealthier means you have AC and better shelter, does that create unfair risk pools?
It absolutely raises those complex equity issues. How do we ensure a just transition and support those most affected?
Okay, so faced with all this, the urgency feels immense. Where do we go from here?
The urgency is immense. As we said, the current changes are far outside natural variability. We're in unprecedented warming. Continuing this way pushes us towards climate states not seen since crocodiles were near the North Pole.
Not a future we're adapted for.
Not at all. This isn't some far-off possibility. It's happening now.
So what's the number one most fundamental action?
It really comes down to replacing fossil fuels, aggressively shifting to renewable energy sources like solar and wind.
Because they don't produce greenhouse gases when generating power.
Exactly. And a huge co-benefit is that moving away from burning fossil fuels immediately improves air quality by reducing harmful particle pollution. That's a direct health win right away.
Okay, so energy transition is key. What about adapting to the changes already baked in? Our cities, buildings.
Adaptation is crucial too. We need to make our built environment more resilient, especially to heat. Designing buildings for passive cooling, good ventilation, shading, green roofs.
Using less energy to stay cool.
Right, and employing efficient technologies like heat pumps, which can both heat and cool very effectively. It's about integrating climate resilience into urban planning and building codes.
And what about the role of local knowledge? You mentioned fishing communities earlier. How important is that bottom-up perspective?
It's incredibly important and often undervalued. Community-level assessments, incorporating local observations, fishermen noticing changes in catches, farmers seeing shifts in seasons.
They're on the front lines.
They are. Their knowledge provides early warnings, can guide scientific research, make data analysis more relevant. Communities often develop short-term coping strategies out of necessity.
Like finding alternative food sources or changing livelihoods temporarily.
Yes, but what's needed are long-term, sustainable adaptation strategies developed with them. Things like local organizing, better early warning systems tailored to their needs, support for alternative livelihoods, adding value to local products.
So empowering local action.
Critically. And then, crucially, integrating those local plans and concerns into the bigger picture regional and national adaptation planning, making sure those voices shape policy.
That makes sense. A blend of local knowledge and broader strategy.
Yeah.
How does international cooperation fit in these big UN frameworks?
They're the essential scaffolding for global action. You have the UN Convention on the Law of the Sea, UNCLS, the UN Framework Convention on Climate Change, UNFCCC, with the Paris Agreement, the Convention on Biological Diversity, CBD.
Do they specifically address climate change's impact on oceans, for example?
Yes, in different ways. UNCLS's definition of pollution is broad enough to cover climate impacts. The Paris Agreement mentions oceans in its preamble and connects to the UNFCCC's mandate to protect carbon sinks, which includes oceans.
Okay.
The CBD works on marine biodiversity conservation, including guidance on impact assessments that should include climate change.
So the frameworks exist, but maybe need better coordination or stronger implementation.
Exactly. There's work ongoing, for example, getting ocean acidification explicitly into new biodiversity targets, standardizing how we measure things across conventions, like carbon accounting for deep-sea ecosystems.
Making sure everyone's using the same measuring stick.
Sort of, yeah. And while Sustainable Development Goal 14.3 targets ocean acidification, unlike temperature, there isn't a globally agreed safe level threshold for pH. So, yes, strengthening cooperation and coherence across these global processes is vital.
Which brings it back to us, really. Individual actions, collective responsibility.
Ultimately, yes. Because it's human-induced change, it is within our power to limit it, but it requires aggressive collective emission cuts.
So what can individuals do?
Talking about it is huge. Breaking the climate silence, Asking questions, understanding your own impact, making informed choices.
But it's not just about individual choices, is it?
No, absolutely not. While individual actions matter and can create ripple effects, we also have to push for systemic change, holding corporations and governments accountable for the policies and the large-scale emissions that are shaping our climate. It's both hands.
Right. Individual and systemic action. This has been quite the deep dive, really illuminating, if also quite sobering.
It is sobering. We've seen climate change isn't just one thing. It's rapid, it's human-driven, and it has these profound, interconnected impacts everywhere. Deep oceans, daily lives.
Demanding urgent, multi-level action.
Absolutely. The changes are systemic, profound, affecting the very foundations.
So for you listening, here's maybe a final thought to chew on. Given these deep systemic changes we're seeing unfold, how might our very idea of home, what feels familiar, stable, reliable about our planet, how might that need to adapt as Earth itself rapidly redefines its patterns?
That's a powerful question. And we do encourage you, if you're interested, check out resources like the Future Urban Climates Mapper we saw in the sources. See potential impacts for your own area. Keep asking questions, keep engaging with this. It's critical.